Morning, everyone. Guys, am I audible? Since we were discussing with how a hacker can try to identify some vulnerabilities and launch attacks on the network or maybe onto a server. So now let us see, in case say hacker is not a say a hacker wants to proceed with launching the attack or trying to take control of by cracking our passwords. So if you guys recollect, we were discussing about what kind of attack methods hackers are generally using. So the first method is hackers try to identify vulnerabilities on the target systems, and based on these vulnerabilities hackers are trying to launch attacks, right? So the second method is hacker tries to identify if there is a possibility for the hacker to steal your pass directly gain access to the issue, right? So here, when you speak about what actually is password cracking, right? So password cracking is the password authentications, right? So that you will not be restricted by any kind of user authentication system before you get access to the data, right? So for this, there are different techniques that hackers are using, like say uh, brute force or dictionary attacks, rainbow tables, sniffing, keylogging, social engineering. So hackers use different methods to perform this password cracking. So the first thing that we have to discuss here when you speak about passwords and password cracking is something called cryptography. Right? Have you guys come across this term, cryptography? Okay. So here, when you speak about cryptography, this is the name of a process that you follow in converting normal data or clear text data from readable format to unreadable format. Now, say for example, I have some data. Let's say I'll consider it as say some ABC123. So this is the data. Now assume this is also the password of my uh, user account. So if this is the data, can someone see and read it? Can they understand what exactly is the data? So someone can see and understand the data, right? Now let us say, instead of writing my password or the data as say ABC123, if I write something as like this, will it be easy for someone to see and understand what exactly it is? I've just taken some random characters and all this, alphabets, numbers, sometimes even special characters can be included. So if I have some data in this particular format, can someone easily read and understand what exactly it is? No, it will be difficult, right? So they don't understand this, right? So the process of converting your clear text data into this unknown format or unreadable format is what you call as encryption, right? So here, the data that you are able to see and read, right? So you call this as clear text data, and this particular string, what you see here, which is not easily readable, we can't easily make out any meaning from this, right? So this you call as a cipher, or you can also call it as ciphertext. So the process of converting your clear text data into ciphertext, you call this as encryption. So is this clear, everyone? Yeah. Now when you speak about encryption, this is bidirectional, means you will also be able to reverse it. Means the ciphertext can be converted back to clear text. Ciphertext can be converted back to clear text. So this particular process, converting ciphertext back to clear text, you call this as decryption. You call this into ciphertext, you call it as encryption. Converting ciphertext back to clear text, you call this as decryption. So is the difference clear, guys? Difference between what is encryption and what is decryption? Okay, yeah. So the combination of this particular process, encryption and decryption together, you call it as cryptography. Okay, so where do we use this? Right. Now, when you speak about cryptography, you can use it to securely share data within your network or over internet. So now my clear format. Right. Now, can I forward this data maybe within my LAN or over internet? So maybe from system A, I want to exchange data to system B. Can I encrypt all the data and send it to system B and then let the system B perform decryption? What do you say? So here, when you speak about encryptions, right, you will be able to encrypt all the data, right? Send it, is your data, can decrypt it. So that's the reason you have two methods, encryption as well as decryption, converting ciphertext back to clear text. Right. So here, when you speak about where exactly we use this, uh, I'll give you some examples. One is your SSL communication. Now, guys, when you try to browse internet, you're trying to access websites. what are the protocols you are using? That you are using? So you use either HTTP or HTTPS. So are they both same or are they different? They are both different. So what's the difference between them? Can someone help me with that? So here when you speak about HTTP, TP, you don't have any kind of encryption, right? So when you speak about HTTPS, you will have encryption. So whatever data that is being sent from user PC to the server will be encrypted if it is a HTTPS connection. If it is a HTTP connection, it will not be encrypted. Okay, so is the difference clear? Yeah. So this is one example, right? SSL communication is what you call for HTTPS sessions. So SSL is one usage, right? Everywhere you are using this HTTPS, and also your messenger applications. Um, if you use these applications like say WhatsApp and all, whenever you are trying to send a message, it gives you a message, right? You can see some message will be displayed which says uh, chat or communication to so and so contact is end-to-end encrypted. Have you observed that? So when you're using some chat applications at all, they are trying to encrypt your messages so that except your mobile device and the recipient mobile device, no one else will be able to see what exactly is the data, right? So when you speak about cryptography, the common terminologies, as I said, plain text or clear text is a data which is in readable format. Ciphertext, the data that is converted into an unknown format, right? Encryption, process of converting your plain text into ciphertext, and decryption, that's the reverse, converting your ciphertext back to plain text, right? So that's what we were discussing earlier. Now here when you speak about the cryptography, you see there are two different scenarios on how this is being implemented, right? How exactly this is being implemented. There are two encryption. So I'll explain you what's the difference between them. So these are the two different methods using which cryptography can be implemented. So the difference here is when you speak about symmetric key encryption, it uses the same key for both encryption and decryption. Remember, we text and then decryption, converting ciphertext back to plain text or clear text. So for this data conversion, in case of symmetric key encryption, same password will be used. But if you speak about asymmetric key encryption, right? Instead of same password, you will have two different passwords. You call them generally as a public key and a private key, right? So you'll have two passwords instead of one password. So in case of symmetric key encryption, there is only one password for both encryptions and decryption. In case of asymmetric key encryption, you have two passwords, one for encryption, the other for decryption, right? So these passwords in asymmetric key encryption, we call them as public and private keys, where public key can be exchanged over internet. As the name says, public key, it can be exchanged over internet and is used for encrypting your data. And these private keys, they are not exchanged over internet, and private keys are used for decrypting your data. Right. In case of symmetric key encryption, there is only one key, only one encryption key using which you do the encryption as well as decryption. In case of asymmetric key encryption, instead of one encryption key, you are going to have two keys, a public key and a private key. Public key will be exchanged on internet. Private key will not be exchanged on internet. That is the primary difference. The secondary difference, public key will be used for performing the data encryption. Private key will be used for performing data decryption. Okay, so is a difference is clear here between the symmetric key and asymmetric key encryption methods? Yeah. So now, so this is how things go on. So when you say the symmetric key exchange, excuse me, the symmetric key exchange method, as I said, you'll have the same password, right, for both the encryption as well as decryption. But if you speak about asymmetric key, as I said, you have two different passwords. So let me show you a simple example. Now let's say um, I want some data to be sent from system A to system B. Now these two systems may be within the same LAN network or maybe they are on internet, right? So the physical location of these two systems is not going to make any difference. They may be within the LAN or they are on internet. You can perform encryption. Now let's say I want to use symmetric key encryption. Now there is some data which I wanted to send from system A to system B. Now I'll use a encryption key as say ABC123. So ABC123 is the encryption key, or in a simple plain text language, you can also consider ABC is the password using which I'm going to encrypt this data. So ABC is the password using which I'm going to encrypt this data. Right. Now source is system A, destination is system B. So I have to send this data from system A to system B. So once system B receives this data packet, will system B, will it be able to open the packet and see what is the content that I have sent? System B, will it be able to see what is the content shared by system A? It will be able to see the contents sent from system A. So even before this data is being exchanged, both these systems have to communicate with each other, saying that let us use ABC123 as the encryption key. So these two systems, system A and B, have to communicate with each other, saying that let us use this as our encryption key. Now assume there's a hacker who is listening to all this communication. Assume there is a hacker who is listening to all this communication. Can this hacker know what is the encryption key being used? Will a hacker know what is the password they are using? Hacker knows what is the password they are using, right? So if hacker knows what is the password, can this hacker decrypt the packet and see the data or maybe modify the data? So there is a chance that if there is a hacker listening to communication between system A and B, hacker can capture the packet, open the packet, make some modifications and resend it. Right. So you're trying to perform encryption, but are you achieving a very good level of security? You're not getting very good level of security, right? Because see, there are two issues. One, hacker is able to capture your password, right, when you are exchanging it. Second, once the password is known, hacker can easily decrypt the data and see what exactly is the data, right? So then what's the point of doing encryption if a hacker is able to open it and view the data? So you're trying to do encryption, but you're not getting the required security. Is that correct? So to overcome this, instead of symmetric key exchange method, we go with asymmetric key. So let me show you what happens with asymmetric. Maybe they are in the same local network or they are somewhere on internet, right? Now what system A and system B does, instead of using a common password, right, system A will take up some password. Now let's say something as ABC123, and it generates two passwords. Or let me keep it simple for you to understand. What system A does, it creates two passwords: public A, private A. System B also creates two passwords: public B, private B. Okay. And then both the systems will exchange their public keys. Public key A will be given to system B. So now system B is receiving public key of A and system A receives public key of B. So now you will have the public key of A with system B, and you will also have public key of B with system A. Now when data has to be encrypted and sent from system A to system B, system A will try to perform encryption using system A. The source will encrypt the data using the public key of the receiving system, right? So in this case, what happens? Both the systems have created their own public and private keys. System A and system B both have created their own public and private keys, but they are only exchanging the public key. Now, even if I assume there is a hacker here, hacker will only be able to capture the public key of A and public key of B. And these private keys are not exchanged on internet. So hacker will never get what is a private key, right? And when system A has to encrypt some data and send to system B, it will always encrypt it with the public key of the remote system. So system A has received public key of system B. So it is going to encrypt the packet with the public key of system B and send it to system B. Now what system B does, system B, so this is for encryption by system A. Now what system B does for decryption, it will use its private key and decrypt it. So system B will use its private key to perform decryption. So if this method is used using two different passwords, one created for encryption, one created for decryption, and you use these two different passwords in combination, is there a possibility for hacker to, will it be possible? It would not be possible for hacker to decrypt your packet, right? Because hacker does not have the private keys. So without the private key, hacker will not be able to decrypt your packet. So can I say this asymmetric key exchange method is better than symmetric key exchange method? So asymmetric key exchange method is better than symmetric key exchange method. It gives you data encryption and that encryption cannot be cracked. But earlier in case of symmetric key, because the same password is being used for both encryptions and decryptions, that particular password can be captured by a hacker and it can be cracked. Now, when you speak about a simple example, right? Um, do you guys use applications like, say, WinRAR? So in WinRAR, you have an option to password protect your RAR file. Have you used? So there we are using the same password for creating a RAR file and also for uncompression, right? That is for compressing and decompression. That is to create a zip file and to unzip, you are using the same password, right? So you consider that as symmetric key exchange. The same password will be used for both the encryption as well as decryption. Now, when it comes to asymmetric key exchange, right? So here you have to understand a few more things, right? So when you speak about this public and private keys, as I said, the public key will be used for encryption and the private key will be used for decryption, right? This is mostly used in your SSL communications or even by your messenger applications, your WhatsApp, Facebook Messenger, all this. They use this kind of asymmetric key encryption. I'll show you how exactly they look like. Um, let me share my VM. You're all able to view my VM page. Now here, when I access this HTTPS web page, you HTTPS. You're all aware of it, right? So here, you can also check this on your computer, right? So here, Google server to my web browser, right? So there is a HTTPS certificate that is given by Google server. They are giving you something like public value, or you can also call it as public key, right? Now see this, there's some string which you see. This one, this particular string, what you see is the public key of Google server when it is communicating to my computer, right? So whatever data my computer has to send to Google, now let's say I want to search for something, right? Google server, right? So that data, whatever is being sent from my web browser or my computer to Google server, is encrypted with this public key, and that will be decrypted by Google server. You got an idea what's happening with the public and private key? Yes, this is asymmetric encryption. So in asymmetric encryption, as we discussed, you'll have a set of public and private keys, right? You'll have a public key, private key to decrypt the data, right? So here, whenever you're trying to browse internet, whenever you're trying to access some website, you'll see that the website is having a lock symbol. It shows you a lock symbol on your web browser. So it means it is a HTTPS web page. So that HTTPS uses this asymmetric key encryption, right? So where you'll have, you see here on this SSL certificate, the private key will not be disclosed. Private key will be there on the remote server. So whatever request has to be sent from the what do we say, like your web browser or your client, will be encrypted using this public key and sent to the remote server. Is that clear? This is not your public key, this is the server public key. Now see, when encryption happens between system A and system B, system A has to encrypt the data using the public, using the public key of system B, so that system B will use its private key to decrypt the data. one password for data encryption, the other password for data decryption, right? So when your computer is sending data to someone, right? Your computer is sending data to someone, you will use their public key, encrypt all the data and send it to them, right? And the other system, whoever is receiving the data, will use its private key to decrypt it. Okay, you got the concept? What happens in asymmetric key encryption? No, Harish. Whatever you. Key encryption you see with your HTTPS communications and all. So can you hear me now properly? So when you speak about the web browsers and all, right? Communication between your web browser and the server and all, they use this asymmetric key encryption. So for application, right? For applications like WinRAR, where you try to zip or unzip them using a password, it is symmetric key encryption. So asymmetric key, there will be two passwords. Symmetric key, there is only one password. So that's the main difference. Is that clear, everyone? Now, when you speak about the cryptography part, in addition to the encryptions and decryptions, you will also have one another aspect. You have one more concept here called hash value. Now, this hash value is a one-way process. Now, let's say I have some data, something like ABC123. I have some data ABC123. Now, on this, when I apply a hash algorithm, when I apply a hash algorithm on this, right, and this cannot be reversed. So the clear text data can be converted into a hash value, but hash value cannot be converted back to clear text. In encryption, what is happening? In encryption, you are converting clear text to ciphertext part. But in case of hash, it's not like that. What happens with the hash? All the data, whatever you have, right, will be considered as one unit and a value is calculated. So for the data, whatever you have, it is calculating a value, and this value is fixed length. So whatever hash value you have will be fixed length. Input can be anything. Input can be one character or take it as algorithm SHA, secure hashing algorithm. The fixed length hash value is going to be 160 bit. So whether your input is 1 character or 1 million characters, output will always remain 160 bit. Right. So that's the main difference between encryption and hash. In encryption, you will be able to reverse the data, right? You'll be able to decrypt it. So in encryption, there's no conversion of data. It's just a value is being calculated. Some value will be calculated here in the hash there, right? So this particular value, whatever is calculated in hash, will be of fixed length, right? So whether you take only one alphabet or you take the entire book of some 10,000 pages, when you calculate a hash, your hash will be of fixed length. If it is say SHA 160 bit, if it is MD5 128 bit, like this. Right. So is it clear? Guys, did you understand what is hash value? For the last 1 minute, I'm waiting for you guys to respond. I didn't speak. Here, a value will be calculated for your data, right? A particular data, right? And this particular value is going to be of fixed length. So irrespective of your input can be of any length. It can be 1 character or 1000 characters or 1 million characters. Your output will always be the same length, right? So if I consider something like a hash algorithm, SHA, secure hashing algorithm, output will always remain 160 bit, right? And this hash values hash, right? Is it Audible? Guys, can you hear me? Yeah. So what I was saying is, when you speak about the hash algorithm calculates a value, right? A hash algorithm calculates a value for whatever data you have given as a input, right? So whatever data you have fixed length, right? So if you